Hi everyone, this is 𝗟𝗘𝗖𝗧𝗨. Today is the last lecture. Okay, it's your last lecture in PMC before you take your physics paper 2 days after. And it's also, hopefully, my last lecture in PMC as well. Every year I said that, every year I hope to retire the next year. But every year I have to come back again. Okay, all right, that is the last lecture for both of us. And we have on-site students in PMC Paya Lebar. We have a lot of online audience. We have 55 of you over here. I will need you all to get ready 2 things. Number 1, the physics secrets and close. Number 2, you need to get ready blank paper. Okay. Today, lesson is only 2 hours special lesson for you before you take your A-level. So I have designed in this manner. The first one is I will talk about the A-level paper. What you need to do, how much time you have. Second, I will talk about the mentality where you take the paper. And lastly, I will talk about secrets and close. Okay, now let's talk about the first part over here. All can see my screen. Your first paper is actually paper 2. Can you see in red color? Paper 2. Now for paper 2, which is on, is it Monday? It's a Monday, right? So are you all ready for paper 2? Paper 2 is one of the more difficult paper compared to paper 1 and 3. I mean, that's my personal opinion. Do you think so? Paper 2. Why? Because paper 2 consists of database question. And a lot of people feedback that they don't have time to complete paper 2. Now, let's talk about time. I think you all should have 2 watch when you go to the exam. And don't wear it on the wrist, put it on the table. 1 watch shows the real time. 1 watch shows the stopwatch. Now, let's look at the time given for paper 2. 2 hours, and you have 80 marks. Can you help me? Anyone calculator help me? 120 seconds, you divide by 80 marks. Let me know how much time we have per mark. Okay? So, you have 2 watch on the table. 1 watch shows the real time. 1 watch is a stopwatch to show how much time has passed. How much minute per mark? 1.5 minute per mark. All right, so it's about 1.5 minute per mark. So therefore, when you look at the question for paper 2, let's say it's a 2 marks question, you will know it's about 3 minutes. So you always use the stopwatch over here, okay, to gauge. Now, generally, I would prefer to gauge by a 10 minutes cycle. Example, every 10 minutes will be 15 minutes. Every 10 marks will be a 15 minutes. Every 10 marks will be a 15 minutes, okay? So please keep watch of your time. And if we look at the paper 2, you have 20 to 25 marks of database question at the end. So you got to reserve at least half an hour. And I recommend strongly to reserve 40 minutes. 40 minutes or 45 minutes for the last question, database question. That will be the longest question at the back with graph and so on. Now, for database question, if you are very stressed, very hard for you to comprehend what they are asking. If you don't even know what they are asking, how can you answer their question, right? So therefore, 40 minutes at least. So meaning you only got 1 hour and 20 minutes to complete the first part of the paper, leaving yourself with 40 minutes. So stopwatch, 1 side, 2 watch, those who just joined me, 2 watch, 1 is stopwatch to show how much time has passed, to count down to 2 hours, right? So you will know. Okay, the other one is show the real time. Now that will be on Monday, paper 2. No matter what happened after Monday paper, right? Can do, cannot do, I do not want you to be too sad. And I also don't want you to be too happy. Because when you think that you're doing very well, you might not be doing as well as you think. When you think you're doing very badly, you might also not be doing as badly as you think. All right, so actually, I want you to stay neutral after Monday paper. After paper 2, what's the next paper? After paper 2 will be paper 3. Very good, because 2 days after, so just nice. You have already consolidated the topic for paper 2 already. So you know every chapter, every concept, every question type already, isn't it? Then you go to paper 3. Paper 3, 2 hours also. But there is actually a difference over here. The difference is that the weightage is different. Every single mark in paper 3 have a slightly higher weightage. Okay, not so important to you. Okay, timing is the same, 1.5 minutes per mark. So time yourself. But I want to special mention about paper 3 is because paper 3 got 2 parts. The first part is compulsory, you do all. So again, I mentioned I want to watch. If you can, you have to watch or not at home? Got huh? To watch. Can bring smartwatch or not now? You cannot bring smartwatch, right? So just to watch. If not, borrow from someone. Okay, one stopwatch, one normal watch. So 60 minutes, time yourself. When do you need to complete session A? Time yourself, 60 minutes. 1.5 minutes is a maximum. 1.5 minutes is a maximum. You mean you don't go beyond that? Normally for our skill, because I believe all of you are quite good, right? You don't need 1.5 minutes per mark one. You only need about 40 seconds per mark. Okay, so 1.5 minutes is a worst case scenario. Reserve for grade A question. Reserve for difficult question. Then you use 1.5 minutes. Sometimes exceed 1.5 minutes is okay because the question is difficult. You want to invest more time in that mark. We are okay. All right. Most of the one mark, we only take 40 seconds. Okay. Now you check how much time. Can you help me calculate 60 times 1.5? It will be 90 minutes, right? Okay, 90 minutes would be 1 hour, 1.5 hour, 90 minutes. So 1.5 hour, you left with half an hour to choose 1 out of 2 questions. Actually, this 30 minutes, right? Not enough. You put 30 minutes, right? Not enough. Because you got to choose. And in the end, right, about half the cohort do both questions. Because you will not know which question to choose until you do them, right? It's like not like you look at them, you will know. You rather do it, right? So, okay, our advice, the school advice, the teacher advise you on this. They say, do not do question, only do one question. But they don't understand our pain. Our pain is we don't know which one to choose. We want to maximize the score, right? Now, so we do not know. Now you choose your best question that you think you want to do, all right? Leaving aside time to change question. So the moment you start session B for paper 3, at the moment you start, you time yourself within 5 to 10 minutes interval. That 5 to 10 minute interval, I want you to decide. You want to change or not? You decide. You must ask yourself, want to change or not? Say don't want means move on. You can't say I don't want to change and then you keep thinking, oh yeah, what if I change? Will it be better? No. You change or you don't change. All right. And if you want to change, you don't say, well, I think just now is that better. All right. Because you have a low, you have a lower than a low. All right. So you have a high, you have higher than a high. You decide and then you just stay put. Because you only got 30 minutes. My advice is that always when just a database, I say better give yourself at least 45 minutes. Better. For paper 3, right? 2 questions, choose one, right? 30 minutes, highly stressful. I recommend at least 40 minutes. So meaning your session A too faster. Not anyhow do, but too faster. All right. Do at your normal pace. Actually can one. All right. That's paper 3. Now, my issue and my concern after all my years of teaching, right, is you all don't care about paper 1. That's my concern. Because by the time you left with physics paper 1, right, you already holiday mode already. It's like nothing already. Everything is over already, right? You're waiting to go overseas already. Then who cares about paper 1? And then worse still, only 1 hour. But please, everyone, the weightage, if you calculate the weightage, it's 30 marks. The weightage is actually quite high. It's still as important as paper 2. Can you see that? It's still very important. But if you look at the time, 60 minutes, right? 30 questions, that means you got 2 minutes. Paper 1 is the one that you have more time. 2 minutes per question. Note, so again, stopwatch on one side, normal watch on one side, stopwatch, time yourself. This one is the easiest to time. If I'm you, right, every 5 questions, 10 minutes. Every 5 questions, 10 minutes. Never exceed. If for a moment, I mean, if I give you 30 questions, you will not be sure, right, on some of them. If you're 1% not sure or more than 1% not sure, you put an asterisk at the question number there, put an asterisk there, so that you will come back to it later, but you still choose the best answer. Why? Think about it. If you spend 2 minutes to try to solve the MCQ question, then after 2 minutes, cannot do. Worse still, you exceed 2 minutes, 2.5 minutes, because you cannot let go. I can solve it. How can I not solve a measurement question, right? I will know the area of Singapore. How can I not calculate the area of Singapore? So you cannot believe you cannot do it, because you are so good, right? At the moment, after 2 minutes, you still cannot solve. I still want you to choose the option. Why? I do not want you to waste your time in that 2 minutes. If you want to meet a guest, the best time to meet a guest is after the 2 minutes, where you try so much. All right. So therefore, no question is going to be empty. everything is going to be shaded in OMR. You still use OMR now, right? Can I ask you, when you shade OMR, right? Do you do the whole paper then shade OMR? Or you do one question, you shade OMR? After every question, you shade OMR, right? You shade, right? You do not do every question, then you shade. No one will do that. Okay, you will be only one in Singapore to do that. Okay, number one. Not sure, still must choose the option A, B, C, D, 25% probability. I can tell you, guys, if you use my SOP, 35% probability can double up to 50%. You surely can eliminate two option one. Two A, B, C, D, you will know which two is not correct one. You will know. So most likely it's around 50% probability of getting the right answer already. So I still want you to choose, even you say, I cannot, I don't know how to do it. I'm confused. You still want to choose, all right? Shade the OMR. Do not leave it to the last step, then you shade your OMR, okay? Paper one, I can tell you, very important. Now, our greatest fear is that the three paper is to, can I ask you, I don't know everyone, because I don't know most of you, right? So I'm not going to talk to the online audiences, or most of you do not want to on the webcam, okay? Now, so I will talk to the on-site audience. Now, let me ask you, how confident are you to, what do you think you'll get for A-level? Can I ask you? I start from here, second row. Just tell me, don't be embarrassed. I will not say you are very humble when you say, I think I'll get a U. Okay? I will say you're arrogant if you think that you will get an A. Because how much you think you will get depends on your past experience, how much effort you put in the past. Not now. It's not about this instant of time. It's about what has passed. Is that right? So can you tell me what you think you will get? A, next one. B or A? Only one grade. A or B? Depends on the paper. Okay, I comment about that later on. You? B or A? You start the trend. You start B or A, and everyone will say B or A. You? A? What's that? Say. A, say. A. Now, most of PMC students go into the exam hall, they will get A. Okay? Unless, of course, if you join very late, a few months, then of course it will be like not very sure, maybe B or A. But will anyone get a C? How hard it is to get a C? You want to get a C? I can teach you how to get a C. You want me to teach you? Don't memorize definition. All right. Don't memorize definition, number one. Do not care about the question type. Now let me ask back to the first person. I want you to list out, okay? I want you to list out the chapter from the beginning to the end. Start from measurement. Use first. Measurement. Louder. So that the online audience who off their camera, but they can actually hear you, all right? Go on. Measurement. Kinematics, dynamics. Forces. Work energy power. Circular motion. Gravitation. Simple harmonic motion oscillation. You forget thermal. Okay. Thank you for saying, okay, I need to echo you so that they can hear me. So ideal gas and first law together we package it as thermodynamics. Can? And then you talk about oscillation, right? And then you talk about wave motion, wave superposition. Is that right? And then after that, after all the wave, do you forget gravitation? You mentioned gravitation, right? Then after that, after the wave, what do you have? The whole domain of fields, right? Electric field, and then you have COE, right? You have DC, then you have EM, then you have EMI, you have AC, you have quantum, you have nuclear, finish. Now, look at this. They know they will get an A because they already know what is the chapter in sequence. And when you do MCQ paper, do you agree with me that the questions are set in sequence? The first question confirmed will be measurement. Let's guess. Measurement. Are they going to ask me on units, base units? Or are they going to ask me to calculate error? Or are they going to test me the so simple thing, you know, adding vector or subtraction of vector? After question 1, question 2, it will be on kinematics. Is it on graph, displacement, velocity, acceleration graph? Or is it on kinematics equation? Or perhaps it might be on projectile motion. Special question. Is that right? Dynamics. So what are they going to test me on? Drawing free body diagram, F equal to MA, Or maybe recognizing that force is changing momentum over time to calculate the impulse from the area under a force time graph. Or perhaps something I fear will be on collision. Is it elastic or inelastic collision? Now, whatever I'm doing over here, 99% of PMC students can do it. So if you think that because I can do it because I'm the teacher here, you are wrong. 99% of the people around you in PMC know every chapter and every concept. And within every concept, they know every question type. So if you are the only one who do not know, please get it done by the end of tonight. All right, so that is one thing very important. I talked about the structure of the paper already. Okay, now I want to talk about mentality. When you go in to take the paper, most people will understand that they are 0 mark initially. Slowly, they try their best. Every 1.5 minutes, they try to gain 1 mark, 1 mark, 1 mark. Time's up. How many marks? Not sure. Whether A or B or C. And some people, D, E, S, U. Am I right? In PMC, I want all of you to go into the exam hall with the mentality that you get full marks. Because you already know the chapter that they're going to test, right? You know the concept that they're going to test. Like dynamics, you know they're going to set on collision or explosion. You know the SOP. So am I right to assume that you should go in with a full marks and mentality? But of course, there will be some question that you can't solve because it's outside of the SOP. My fault. And it's outside of your HQ, your IQ, your fault. Sometimes your fault and sometimes my fault, right? Outside SOP, my fault. Sometimes outside of your IQ, cannot solve, your fault. We each take some blame. But at the worst case scenario, -1 mark, -1 mark. We start with full marks. You -1 mark, -1 mark, -1 mark. How many marks can you lose? It's quite difficult to lose a mark, right? How many marks can you lose? At the end of the day, you definitely will still get the A. All right? Do not allow yourself to reach a stage whereby you cannot complete a paper. After you cannot complete a paper, you WhatsApp me, you ask me what will happen to you. I cannot tell you the truth, but I know the truth is that you will not get the A. Because you cannot complete the paper, means you start with what? From 0. The entire question is from 0. So it's not going to be easy to get an A. Especially the trend now is my greatest fear is the paper is too simple. Okay, all right. So mentality is full marks and slowly take away 1 mark. Everyone get rid of secret enclosed. If you don't have secret enclosed with you, those at home, okay, you should take a few pieces of white paper, plain paper. Now, initially, I asked myself, what do I want to do in my last lecture with 𝗟𝗘𝗏𝘃? I actually spent a lot of time to compile. Let me show you this. The best of A-level. That's cool, right? I can actually sell it in the bookshop. The best of A-level. So I look at A-level question and look at how they set the A-level question. And of course, you know, I will choose a more difficult one, right? So I compile, and it takes a lot of time. From 20 years, I compile the best of A-level. And I choose only MCQ because if I don't choose MCQ, I cannot complete anything in 2 hours, right? So I decided actually initially to let you do it. Then I realized that doing this paper on the last lecture is not very good. It will not boost your morale. Okay, some of you will be so upset that you cannot even pass. Because to be very fair, it's the best for A-level. Meaning it's all the grade A question in the last 20, 30 years. So I decided not to even give it to you. Because at this moment, what we want is the confidence to be sky high, not super low, right? So therefore, instead, I want to talk about secrets enclosed. Everyone, get ready your secret enclosed. Secret enclosed has been the Bible for PMC since 14 years ago. We've been using that to score A. And every year, from time to time, we improve it. If there is any question set in the exam, be it in the A-level or the prelim that's outside secret enclosed, I add on. But I do not necessarily want to add on every single thing so that such that one chapter have 10 concepts. It's not the idea, right? That is not the secret enclosed. Secret enclosed is to be able to categorize them into as few categories as possible. as few question type as possible so that you can have a global view rather than a local view. Now, I want to run through secret and close with all of you. And from time to time, I must show you an example of a question that require your IQ in addition to the SOP. Most of the question can be solved by SOP without any further IQ, but some require. So we thought about it in a very casual way. I don't really need you to copy down anything and everything. I do not need that. Okay, because 2 days later is your exam ready. Okay, unless you want to copy down for your younger brother and sister. Okay, all right. So I'm going to just open a new empty page here. And I'm coming back to my secret and close. Now for measurement, what can we set in measurement? The first question that we can set in measurement would be on units, base unit. There are 7 of them. I want to give you a special mention. SI unit is not base unit. Example. So I just use a plain paper over here. You want to scribble, you can scribble. For me, it's for me just to write freely on a whiteboard. Can you understand? So for example, you say force. What's the SI unit of force? It's actually Newton. But is that a base unit? No, it's not the base unit. The base unit is kg, meter, second minus 2. You say pressure. What's the SI unit? Is Pascal. But is that a base unit? No, it's not the base unit because the base unit is the force is kg, meter, second minus 2 divided by meter squared. My advice to you is that for the concept 1 on base unit, it can appear in both MCQ and also paper 2 or even paper 3. Okay, for paper 2 and paper 3, okay, when you show your working, try to avoid cancellation, especially when the power becomes minus. I know your math are better than my math, okay, but I do not like you all to make cancellation to simplify. I prefer you to just simply see a kg, write down kg, see a meter, write down meter, see a second, write down second, then write down the power. Power kg is 1. Power meter is 1 minus 2 minus 1. Power minus 2 at least. That is linear. One line. Do not do cancellation because cancellation you might make careless mistake. That's my advice. To avoid careless mistake. So I'm talking about unit. There are actually 7 of them. I memorized them. The first 3 is the most commonly used, circle, kg, meter, second. The next 3, the first one is Kelvin, belongs to temperature. The next one will be ampere, belonging to electricity. Some people think that Coulomb is a base unit. Okay, and then if you have mole, that is of course from the chemistry, the amount of substance. The last useless one will be candela. There are 7 of them. What are the question type under the first concept? Of course, we say find the base unit. Is that right? So you got empty paper, right? I test you. So I think by PNC standard, you only need 30 seconds. Okay, SI unit is ohm. Ohm is for resistance. Give me the base unit for resistance. Thank you, Joel. Can you let me know what is your answer? All right. Let me know what is your answer for base unit of resistance. Send to tutor chat box. Okay, time's up. That will be 40 seconds. Fast enough. Okay, some of you look at me like, hey, don't believe me, Don't believe me that 40 seconds passed. So let me use stopwatch. Let's use stopwatch. Where's my stopwatch? Okay, I will have a stopwatch of 1 minute. Let me have a stopwatch 1 minute over here, so that when I give you a question, you know how much time has passed. Can I go over the next person, second row? What's the answer for resistance in base unit? Yeah. kg, meters square. Second, minus 1. Ampere minus 2. That's our answer. Okay, that's the answer. So all of you A student, right? Okay, you want A, you should get A1. Okay, is it your answer? Is it the same? Your second is power minus 3. Minus 1 or minus 3? We check. Minus 1 or minus 3. Some say minus 1, some say minus 3. Minus 3. Why you make cancellation mistake? Can I check? Do you do cancellation? No, okay. Now let's look at it. All right, students. And let me see, Joel, kg meter squared, second minus 3, ampere minus 2. Well done, well done. Okay. This question, you know how to do, right? Maybe you say so easy. But actually, if I go to your school and I conduct a lecture for your school, half your friends cannot solve this. Okay, it's like this. Half your friends cannot solve this. That is the standard right now. Okay. Now, some of them will be very funny. They use rho L over A, which you think is amazing, right? Well, how to use rho L over A? Rho L over A, then this is meter, this is meter square. This is called resistivity, is ohm meter. And then you get back ohm. All right, you get ohm again. So our SOP in PMC is that when you want to find base unit, you do not use rho L over A like that. You must use the equation that's used to define resistance. How do you define resistance? Help me. It's defined as the ratio of PD to the current going through it. All right. So the current already, the base unit is ampere. So voltage, what is the base unit of voltage? When you're not ready, what should you do? You should replace the voltage into other quantity first. For example, you know that 10 volt means you need to do work, 10 joules of work to push 1 unit charge across the wire. So this voltage is work done per unit charge. Agree? Agree? So now you are ready. Are you ready to put in units? If you are ready, then we put in. If not ready, replace the quantity with other quantity until you are ready. Now I'm ready. Let's say, for example, charge. You want me to change to base unit? Am I ready? If I'm not ready, I will say, okay, then I will replace Q with IT, current times time. But actually, I'm ready. My brain tells me that charge is therefore Coulomb, which is ampere second. I'm ready, I put in unit. Not ready, change it to quantity. All right? Work done. Are you ready? If you're not ready, you will say force and distance. If you're ready, you will know that in PMC, we don't use force and distance for work done. We use KE, half mv squared, m is kg, mv squared, velocity square is meter squared, second minus 2. Finish. All right. And then also, do not do cancellation. Rather, I will want you to use kg, meter, second, ampere. You see what unit you write down first. Don't care about power first. Then throw in the power. Boom. Get answer. So that is how you find base unit. So one single concept, I can talk a lot. In fact, if you give me 10 hours, I can use up the 10 hours. Because why? There are more question type than this. There are other question type. For example, homogeneous. Define what is homogeneous. Same what? Same. Homogeneous. If the equation is homogeneous, it means what? Homogeneous. For example, A, B plus C on the spot, I do it on the spot, equal to D. All right. Do you think that the units of A and B must be the same? No, they may not be the same. You multiply units different is okay, right? You divide units different is also okay. That density mass over volume, no problem, right? But B plus C, must the unit be the same? Must be the same. So yellow and yellow must have the same unit, you know. So they will ask you to find some constant. You compare the units. You know that first of all, number one, the units of B equal to the units of C because it's addition or subtraction. Agree? Now, what if I ask you to find the units of A? What should you do? You should go on. Expand. Is that right? You expand. And when you expand, you will know that the next thing you can tell me is that the units of AB, okay, is equal to the units of AC, which is equal to the units of D. Is that right? So with that, you can find the units of D or A, whichever they ask for. And that is called equation must be homogeneous. Homogeneous is to tell you that every term, if it's on expand, if it's addition or subtraction, must be the same. And of course, there's multiplication. You expand it until you get purely addition and subtraction. Then you know every term in the equation will have the same units. Called homogeneous. So is that common? Yes. In math, secondary school, you compare coefficient, right? Physics, we compare power. We check the power of every unit. Left side, right side must be the same. So is this a common question in A-level? Yes. This is a common question in A-level. I'm still at the first concept of measurement. How do I complete until nuclear? Okay, I'm going to expedite more. Okay, I can make it faster. This space unit. Okay. Finding error. Finding error, of course, you must understand that your error must be 1/6 feet. Agree? How you calculate the error of that quantity depending on the equation for that quantity. For example, if it's addition subtraction, you just add out all the error to get the absolute error. So this is called absolute error. And it has to be to 1 SF. If there's a constant here, 6A, what does it mean? 6A doesn't mean 6 times A. 6 times A. I know it means 6 times A, but in physics, PNC call it A plus A 6 times. You think about it, guys. If you add A 6 times, do you think you should add the error of A 6 times? So that's why the 6 must be copied down. You cannot throw it away. All right. If it's minus, you still add the error to get the absolute error. But what if the equation is multiplication and division? You do not find the absolute error immediately. You find the fractional error instead. So this is called fractional. I write down fractional. Fractional error, you can round it off to 3SF if they ask for fractional error. How to find the fractional error? You add up the fractional error of everything on the right-hand side. If C to the power of 3, to me, it means C times C times C 3 times. Do you think it's reasonable for me to add the error of C 3 times? Of course, right? But if there's a 2 over here, do you keep or you ignore or you throw? You throw away because the 2 will be eliminated because the 2 will appear inside the Y. In the Y, there will be a 2. The absolute error on top will also have the 2. As a fraction, the 2 will not be visible anymore. That's why for fractional error, in case 2, you ignore the constant. All right. So that's how you find the error. Of course, if you need the absolute error, you take the fractional error, you times the original value of Y. That's why your first step, some students always forget. The first step in SOP, right? I always ask you to find the Y first. You find the value of the quantity first. Then you proceed to find the delta Y. I do not want you to wait until you reach this stage. Then you need to know the value of Y. You need to times Y, right? Then, don't have Y. Then you go back again. Then you make careless mistake. And then you forget the prefixes. Guys, A-level confirm will hide prefixes somewhere in the table, then the column header, right? Then they put slash centimeter. You forget to see the centimeter. You think it's meter, die. All right. Or 10 minus 6, you forget to see, right? Die. All right. So be careful about prefixes when you find the magnitude of Y. It's a simple thing, right? But don't make that careless mistake. Okay. So that's finding error. Next lesson. We have 2 methods to find the error of Y, and we understand that once you get the error of Y, we will be able to know how to round off the placing of the magnitude. Example, okay, let's say it's 1.42. You round it off to 1.4. Right? You will not give me 1.42, ma. You 1.4. Why? Because my error is 0.1. If you tell me 1.42, I won't care about the 0.02, right? Isn't it? Since my error is 0.1. So that's why we round it to the same placing. Now, my question to you is, there are 2 scenarios over here to find error. What's the third method I ask you to use to find error? Maximum minus minimum. Guys, I write down here, the delta Y will be the maximum. You're confirm A1, I tell you. You're confirm A1. Okay? If you don't get A right, Mr. Singh will not believe one. Okay, you are very ready for your paper. I'm not trying to fake. It's seriously, okay? So you must have the mentality that you really can get full marks one. You even know all this. I talk to you is that you are a teacher, you know. Even teacher may not know this. Okay, maximum minus minimum over 2. Okay, that is whereby you have a third method to find Y. Example, you try to find the maximum value of Y. So if you want to find the maximum value of Y, A and B will be big, right? C will be as small as possible, ma. Then you find the minimum, you find the difference, you get the range, you half the range, you get the error. Okay. Now, I also want to talk about special question in concept 2. One will be, of course, negative power. For us, we know that this one belongs to case 2. The fractional error of Y will be equal to 6 you throw away. You copy down fractional error of A, you add 2 times fractional error of B. You don't care about the negative power, right? Because you know that this one is actually equal to 6A over B squared. So you apply it, no problem. This is called easy question because it belongs to case 2. Agree or not? Agree, yeah? But I suspect that if they're going to set a question in paper 2 or 3, okay, it might be a combination case. This is an example of combination. Why? It has an addition here, and it has a division and multiplication here. But you have a combination case, right? You should do replacement method. Replacement method means that I replace 1 over b squared with x. I let x be 1 over b squared, and then I try to solve for what's the absolute error of x. Once I got the absolute error of x, blue color, I will sub in the absolute error of x over here and I solve. Meaning I divide it into 2 different cases and I solve them separately. This is called the combination case. Now, the A-level set question on combination case before? Always. You want to see example of my best of A-level? Now, I give you best of A-level. Okay, I don't want you to see too much because you see too much, right? You feel, wow, die already. So let me just show you a few best of A-level that I compile. Anyway, I use 2 days to compile. Now I don't give you a very set. I give you an example of the best of A-level. This question has been the debate in school where many teachers think that A-level set the question wrongly, solve it wrongly last time when they set it in the A-level. And I think it's, have you seen it in tutorial? This question? Yes? No, you can see it in tutorial. In your prelim, or one of the paper, then you use maximum minimum method, right? Right, you use maximum minimum to solve. Okay, this question here came out in A-level, and a lot of JC teacher, right, recycle this. Okay, initially they do not know one aspect about the question, but I cannot talk about it because no time. Okay, but generally, right, the best way to solve this question is using maximum minimum method. Why? Because this one is actually addition, right? But again, that's division. True. So of course you cannot say, oh, I know delta f over f equal to delta u over u plus delta v over v. That will be wrong, ma. It will be right only if, let's say, for example, f equal to uv. Then okay. True or not? Agree? But this one is got addition, ma. So the student should recognize that it's a combination case. So how to solve this question? The correct way should be let this one be x or let this one be y then let this one be z then x will be equal to y plus z, right? So the error of x will be equal to the error of red and green together. Agree? Then how do you find the error of x in terms of error of f? Because at the end you want f, right? You want f, right? Then you will solve it out. X equal to 1 over f. You solve it separately. That is by SOP in the secret enclosed. But what's the faster method? The faster method is actually simply to find what's the maximum value of f. So you sub v to be 205. You sub u to be 53. You got maximum value of f, right? Then you reverse to find the minimum f. Then use my method 3 to solve. That will be faster. All right. Then you'll get answer to be A. But there's a mistake in the A-level question. Next person, Kenji. What is the mistake? Answer is A, but there's a mistake. What's the mistake? Can you tell? The error must be in what? 1 sig fig. Don't know why they give me 2.1. But right, error, no one thought about 2.1. If it's an error, you care about 0.1, man. You just care, you just do plus minus 2, 1 sig fig. The sig fig means what? Important. Significant means important, the first important figure. We only want the first important figure. So this is the answer A. Okay. Now just a very quick mention. I shouldn't spend so much time on measurement, right? But I just say okay. All right. A quick mention is that last time the teachers tried to solve this question, right? They do not know how to use the maximum minimum method. They only know about it recently only. Okay. They actually try to combine it. So they actually teach it this way. So they say combine it. So 1 over f, you combine the denominator. Then this one will become v, right? So v plus u. Agree? And then they will say, well, then f becomes uv over u plus v. Okay, that's what they actually do initially. Then they will tell the students that let this thing be x. Let this thing be y. So they have f equal to s over y. So they try to solve it. Delta f over f equal to delta s over x plus delta y over y. They try to solve it in this manner. It looks very legit, right? Can do like that, right? Then of course, how to get the delta x? Because you know that s is u times v, right? Then they try to find the delta s and so on. Now, why is this method wrong? This method actually, it looks very legit, right? But it's wrong. They will get the wrong answer is because the u is upstairs and the u is downstairs at the same time. When you change the equation, you rearrange it into a format whereby U is upstairs and downstairs at the same time, right? Your answer you get will not be A. Why? Because the mechanism behind this is quite complicated. What you're applying in secret enclosed under case 1 or case 2, right, is assuming that you are trying to find the maximum value of Y and minimum value of Y and find the difference, you half it. That's why I call you method 3, right? But when the teacher try to rearrange this equation into this format, right, you apply your case 1 and case 2, right, into this equation. What happens is that the computer try to calculate the maximum value of F, right, by subbing in U to be as big as possible, right? And at the same time, they sub U to be as small as possible. Because the computer do not know. You got it? Because for us, U can be 53, can, right? But can be U, then they say this one they put up 47. But U cannot be 53 and 47 at the same time. So that's why you cannot anyhow rearrange equation until a fact that the same quantity, right, conflict itself. Because you want to be big and you want to be small at the same time to make F big. Cannot. Okay. This thing is even difficult for teachers to understand. But I just tell you briefly why sometimes you rearrange the equation, right? Cannot. I give you another example now. Okay. Y equal to d squared minus small d squared. Okay. You always use this thing when you want to find the, let's say, area of the shaded area of this shaded area. Pi d squared over 4 minus pi d squared over 4. Pi r squared minus pi r squared. You want to find shaded area. So eventually you will have this kind of equation, right? So this kind of equation, right? By right, you should just let this be x, let this be y, right? Then you solve x minus y. It won't conflict. It's very good. It won't conflict. For example, you want to get the maximum value of y. Your d will be as big as possible. Your small d will be as small as possible. Can you see the quantity, right, will not conflict itself. It will not fight against itself, right? But many schools, when they teach this question, right, they again use the wrong approach, and the answer was wrong actually. They don't know it for many years. They ask the student to factorize by 2 terms. I think now most of them know already. Last time they do not know. So they factorize already, right? Then they solve it. They say, let this be x, let this be y. They solve it this way. Cannot. They answer wrong. They don't know why wrong. How come wrong? Correct. This one to this one, mathematically is correct. You are not wrong in any way. You're not wrong. But however, the computer, the mechanism you apply, right, don't know. You want maximum y, they put a small d to be big, right? Big, right? Small d to be big. But you want maximum y, they put the small d to be small at the same time. Conflict again. Conflict of interest. Okay, so that's why you cannot anyhow rearrange. Your equation you rearrange can, but your quantity cannot be 2 different values to achieve the same outcome. Understand? All right. So in general, you ask me, wow, Mr. Sim. So measurement, what is the thing I need to take note? Very easy. If you got combination of case, right? Like this one is called combination of case, right? You use what you do. Maximum minimum method. So to find the maximum F, V will be 205. U will be 53. You find it. Okay. You don't rearrange it until you got this format, right? Then I ask you, how to find the maximum F? Oh, don't know. U should be what? U should be 53, right? And then here, see, 47. Then of course you get wrong answer, right? You rearrange it like this. Agree or not? Okay. I spent too much time already. Okay, I only got 2 hours, not 20 hours. So I just give you an idea of how you should do it before your exam. Okay. Okay. The third concept is on vector and scalar. It's on how to add vector and how to subtract vector. Let me give you an example. Adding vector. Today, there's a river. The river is moving at the velocity of v1. Okay, all this I'm doing it on the spot. I mean, I'm thinking about it on the spot. What can be said? Addition of vector. So we got a vector, the river moving to the right. You are here at point A. You want to swim across the river. You want to take the shortest distance. The shortest distance to go across the river, will you try to go vertically or will you want to go diagonal? Obviously, the shortest distance will be here. Agree? The shortest distance. So you want to reach the other side of the river. Examiner asks you, in what direction should you swim? Okay. Everyone using a simple IQ, right, will know that you cannot swim up. You swim out, you end up here, right? You swim to the right, you end up even worse. Okay, even your parents will know that you should swim here. Agree or not? But the thing is, they will ask you, what angle must you swim to the vertical or to the horizontal? So I ask you, this question, how to solve? Now, this question came out in A level before, and if you look at the 10 series, right, sometimes I don't want you all to look at the solution of 10 series because their approach are not correct or not intuitive to the student. So you read the solution, you become confused, right? Now, many of them thought about this saying, well, this is out of A level syllabus. Why? They feel that this is under the theory of relativity. It's relative to the river. So they talk about subtraction of vector. Actually, this question, A level is the smart person. The Cambridge is the smart one. This Cambridge examiner want to test the student not on subtraction of vector. Not subtraction, but addition of vector. They want you to know that the resultant velocity, right, is the sum, the vector sum of the velocity of the river and the swimmer. This is the swimmer. V2 is the swimmer, okay? V1 is the river. The resultant, what do you want to achieve? Green color is what you want to achieve, right? Green color is resultant. Blue color is you. Red color is the river. So therefore, the resultant should be equal to the river vector plus the swimmer. Am I right? So you want to achieve this. So therefore, you must know what you want to achieve is a resultant. So when you talk about vector addition, V2, you draw. V2 is over here. You add a V1 head-tail method. All know how to use head-tail method. You learn that in Sec 2. Now you J1, JC1, JC2, head-tail method, continuous method. So you know that the resultant must be vertical in green color. All right, resultant. I ask for angle theta. You know blue color, you know red color. You use stochastic to solve. All right, in this case, you know the O, you know the H, sine theta, get answer. A lot of them don't solve it this way because they do not know what the examiner is testing on. They talk about relativity, relative. So you take your speed minus the speed of the river and so on. Make it so confusing. Actually, they do not even know the examiner want to test whether the student know how to add vector or not. Okay? That is called vector addition. I will increase the page to talk about how about vector subtraction. You say, hey, Mr. Sim, you teach me how to add vector, which is a very good classic example. This is a question whereby you set it in an exam, 10-20% can do. Most of them cannot do one. All right. Now, how about subtraction? This one, right, is funny. Okay. This one is like they set this question for many years already. Still, you have quite a big percentage who get it wrong. So the car go to the right and make a turn and then go here, V2. So I ask you, last person, let's say the speed is the same. Is that a change in velocity? Let's say the speed is the same. The magnitude of the two vectors is the same. Is that a change in velocity? Yes, that's a change. Why is that so? Because direction change. The first word you say is because velocity is a vector. When you answer paper 2, paper 3, you go direct to a point. You make a what? First impression that I know. Velocity is a vector. And therefore, even though the magnitude, always talk about the contrasting thing, even though magnitude is the same, but direction change. So there's a change in velocity. That's the acceleration, right? Can you give me what's the direction of change in velocity? Everyone, online students, okay, those who are on the camera, up, down, left, right, or diagonal. Let me know what is the change in velocity, up, down, left, right, or diagonal. Diagonal, tell me diagonal up, down, diagonal down, right. Give me the answer. What is the direction of the change in velocity? Now, answer times up. Give me answer now, okay? What's the answer? What? This one, is it? No. Okay. No. Okay, but in PNC, you all know it's no lah. Right? But your friends, right, will think the answer is this one. Because they learn that since you make a turn, right, so initially it's here, right? Then at the end you are here, right? They will say that this is the change in V. But they are wrong. Because they do not know that this vector actually represents the addition, right? The addition, you add up. You add out the initial and final. This is addition. I'm asking for subtraction. I'm asking for what? For V2, I want you to minus V1. I ask for subtraction. And then you tell me answer is this. But you know what? In the examiner report, so after every A level, right, they will give the school the examiner report, which I cannot show you because they don't allow us to show you. Okay? But every year, this question, right, people choose diagonal down to the right. That is outside PMC. Now, generally, you will see that red color V2, right? You add a minus V1. Minus V1 will be not to the right, but to the left. So you're adding these two together. It's subtraction. You add a negative vector, and the resultant is what you want, which is diagonal down to the left. Okay? So that will be the answer, diagonal down to the left, not diagonal down to the right. Okay, quite a lot of them actually make a mistake. All this, I cannot see you. I hope you're enjoying your Netflix. All right. So Mr. Sim is actually helping you in your last 2 hours to talk about common mistake and running through only one chapter, measurement. How much time have I used up? 1 hour. How much time do I have? 2 hours. I have how many topics? Okay. I cannot do this for you for all the topic, but I'm telling you how you should do it on your own. Okay, when you revise the secret enclosed. One topic only, I take 1 hour. Okay, coming back to secret enclosed. So we talk about vector addition, we talk about vector subtraction. Now I'll go over to the second chapter, and this will be advanced kinematics. I'll tell you what, for kinematics, right, my opinion is that there is a possibility that even though a lot of you are grade A students, there's a possibility that in paper 1, there'll be some question that you may not know how to solve. Because you are good in kinematics, right? The examiner also good in kinematics. You study kinematics since you are set 3, set 4, J1, J2, right? Your examiner, being very older than you, also study kinematics since they are secondary school, lower set, upper set, JC. So you're good, they are also good. So the question that is set are sometimes quite unusual and require IQ. How many concepts are there in kinematics? First thing is graph drawing. How to draw graph from displacement to velocity to acceleration. And second thing would be on equation. So there are 2 types of questions in kinematics. And besides the 2 types of questions in kinematics, there's special question which we call the projectile motion question. Today is not the June holiday workshop. In the June holiday workshop, I run through every single chapter with you in details like this. So there's no need to reteach. But I want to give some reminder. When you encounter a graph question, for a normal student outside, they will say, oh, gradient is velocity. Gradient of velocity is acceleration. Or like area, right? For PMC student, every time you see a graph, the first thing you look at is the axis. What is the graph? You need to know, is it AT graph, a BT graph, or displacement graph? If it's the AT graph, you need to know. You need to know that the AT graph, what does the Y value of the graph represent? The Y value represents the acceleration, obviously, right? But what does the gradient represent? The gradient represents nothing. Don't bluff yourself. Don't keep on thinking that the gradient must represent something. The gradient, the ATT represents nothing. At most, you want to tell me, it represents the rate of change of acceleration. But who cares about the rate of change of acceleration? What's that? But what's the area? The area represents the change in velocity. Throughout the graph over here, the change in velocity is positive, all the way from A to B to C to D. That means that the speed is increasing. And only after point D, then the area becomes negative. If you look at the entire area of the graph, is a positive area bigger than the negative area? Yes. So the speed you gain is more than the speed you lose. And therefore, throughout the journey, you did not come to a stop. So you move faster and faster, you move slower and slower, you did not come to a stop. You only come to a stop if the speed you gain is equal to the speed you lose. If you didn't come to a stop, by looking at the AT graph, I will know that point F must be the furthest away from the origin. Because you didn't even come to a stop. You didn't make a U-turn. So point S must be the maximum displacement. This is a skill set we build into each one of you. Am I right? That by looking at the AT graph, you have the ability to tell me about displacement. That's amazing. Even teacher cannot do that. All right. You go all the way to displacement. And therefore, we have maximum displacement over here. Of course, it all depends on the graph you are given. You are given a VT graph, you must acknowledge, don't graph yourself. You must know the Y value itself is the velocity. Okay? And the gradient is the acceleration. And of course, the area will be the change in displacement, meaning the change in the position, also known as the distance move. Displacement time graph, same thing. Every time consider the Y value, the gradient, and the area. Do not bypass my SOP. That's the reason why I write the SOP in this manner, so that even the question is difficult, you can still manage it. All right. So that is on graph drawing. On equation is something interesting because there are 4 equations that we can use, and we also know what USA vote for Trump now. We do not want to use equation randomly. USA VT, we need to check which one is not involved in the story. Then we choose the equation. I think that one is too basic for you. By the way, you all know how to prove the 4 equation. Don't be embarrassing. The 4 equation to prove is, hey, is it last year or which year is it? They ask to prove the 2 equations, then they give 4, 5 marks. Which year? Recently, right? You all do A-level paper. You all know which year? Who knows? You all can do the paper now. To prove the 2 equation, they give 4 marks. This is like, if you don't know how to do it, right, whole Singapore, right, out of 100 students, you're the only one person who do not prove the equation. Okay, so this one proving, right, the equation, right, must score full marks one. Okay, I will not go through that. Let me show you some grade A question, okay? But don't be too sad if you cannot solve. I need to manage your motivation and morale. Okay, so okay, I just give you one will do. I give you one question that you confirm cannot solve. Okay, question 4. Go. Prove me wrong. You prove me wrong, y'all. Question 4. Let's go. You take pen, right or something. Question 4. Honest students, nice to see whether you all know how to solve or not. Okay. I just on the 1 minute timer. It's quite natural to expect that the time taken is the same, but you move a longer distance between 2 and 3 because you accelerate. Your speed is not the same. By common sense, within the same time, you should travel a longer distance. Using kinematic equation, you decide to choose one out of the 4 equations to use. You try to decide what is the best equation to use. You are pretty upset that there are too many variables given to you. There's S1, there's S2, there's T, and worse still, your nightmare is that the initial velocity is not 0 at gate 1. That's the nightmare. You really hope that the initial velocity is 0, but the initial velocity is not 0. So some of you think that initial is 0, so it's gone already. Okay. So you see, after that 1 minute, I start to tell you that you made an error. If I don't tell you that you made an error, right, you can spend 3-4 minutes. You still cannot get it. You should learn how to give up after 2 minutes. Put the asterisk, choose your best option. The initial speed is not 0 at gate 1. You release the ball at this point over here. A-level question. And of course, somewhere between gate 1 and gate 2, distance travel S1, gate 2, gate 3, distance travel S2, a longer distance. Any online students, Joel? Are you able to have the answer? Hello. So Joel, let's say I ask you, Joel, if you kind of like know you invest 1 more minute, you still want to have a higher probability of getting the answer right. Joel, does it make sense from an investment point of view? You should just stop, put an asterisk, and then you choose ABCD. You don't invest much time, right?
Yeah, just put
Then
C.
Joel, what option will you choose?
I'll choose C.
You will choose C, okay? So he will choose C. I will ask back the front row. What will you choose? or second row? What will you choose? You choose D. All right. Next person. I asked you what is your A-level result. You say it's A or B. Now I ask you what option, A or B. No wonder lah. You can always look at option one, right? What is that? A. You? B. So A-level question, right? Not the same as prelim. A-level question is able to differentiate A, B, C, D. People really choose A, B, C, D. What's the answer? Okay. Let's talk about the pain. What's the pain? Can I ask you, what's the pain? Why you find it difficult? You cannot get rid of some variable. True or not? What is the variable that you hope you get rid of? You really hope you get rid of it, then you can solve already. What's the variable? The U. You want to get rid of me? Get rid of U. Okay, very sad. Okay, she want to get rid of me, right? She want to get rid of U, the initial velocity, because she do not know what's the initial velocity at gate 1. Agree? That is the greatest pain. But the thing is that to solve that pain, right? Why must you start from gate 1? Why must you start from gate 1? Or should you start from gate 2? No. Should you start from gate 3? No. Why not we start from here, where U is 0? Then you get rid of it and solve your problem. We get rid of it first. All right, it's possible, right? Let's just get rid of it. You can do it over here. You always try to choose the point where you want to start. If possible, initial velocity. We try to choose. Okay, that's one option. The other option is, we look at it. If I start from here, do I know the distance traveled here? No. Then by doing that, I introduce one more variable, which is not a good thing. Your idea of solving question is to get as few variables as possible. So therefore, you cannot start from here, right? You must start from here. But here, you know that the velocity is not 0. But I will write it down anyway. The equation, if I can, write down S1, okay, equal to U something plus half A something squared. Agree? So why do I not write the time first? Because I don't want to make any careless mistake. I want to put a bracket first, then I check. Indeed, this is S1, right? The time taken is T. I put down T. I put down here to be T. And you're right, you want to get rid of the U. That is your pain, right? Equation 1. Now, what is the next equation, same person, that you write down? Is it from, if can, I call it 1, and then I call this 2, and then I call this thing 3. Is that okay? So which point are you looking at? Between what point to what point? 1 to 3, because she's very well trained now. Normal person will look at what? Normal person will look at 2 to 3. So if you ask any of your friends outside here, they will look at 2 to 3. And then their first step is to find what? The velocity at point 2. That's what normally they will do it. And they actually incur what? As I mentioned, one more variable. They couldn't find the speed here. That's even worse, right? So she made a wise choice. She already understands that she has a U and she wants to get rid of the U. She looked at 1, 2, then 1, 3 instead of 2, 3. And that is a very smart, very, very smart move. Looking at 1, 3, the distance travel will be what? Distance travel will be S1 plus S2. Total distance travel. Is that right? And again, Mr. Sim do not want to make any careless mistake. You see? I don't commit to mistake. I do things one at a time. Don't need to use brain one, I write down. Use brain one, I ask. What's the time here? 2t. This one? 2t. Okay? And if you want me to simplify it for you, it will be 2 ut plus, this is 4, right? 4t squared. 4t squared divided by 2 will be 2at squared. It will be S1 plus S2, equation 2. All right? I have 2 equations as per PNC SOP so far. You reached these 2 already, is it? Incredible. And you get your answer A. What did you get just now? I forget. Which one you chose? Or you guess on the answer? Or because you reached this step, you don't have to move on, is it? This one because you didn't join Maths Cafe. It's Maths already. Now it's Maths already. Done. Physics over already. Now Maths already. You want to get rid of? You want to get rid of me again? You get rid of you, right? So how to get rid of U? Coefficient of U is 2t, right? So therefore, the best deal will be 2s1 equal to 2ut. Just multiply by 2 lah. Do you agree? Cannot. So that I have 2ut. All right. I make it share the same coefficient, then I get rid of your pain, your pain is U, right? I get rid of it. So should I minus the equation or should I add the equation? Minus, minus equation, right? So my equation 1, okay, or equation 2 minus equation 1, equation 2 minus equation 1. So S2 plus S1 minus S2, S1 will be S2 minus S1. Agree? Left hand side minus left hand side, right hand side minus right hand side. 2UT and 2UT get cancelled away, You get your wish. You see, she know what she want to do, you know. She's not like the type of student who I try my best. She already knows she want to get of U already. 2UT, UT, then 2AT minus 2AT will be what? AT square, right? And then to find A, right? You are right. Answer is A. Okay. Before I go through, it's always difficult. After I go through, it's always easy. All right. So therefore, what does it mean? The outcome of today's debrief is that if you cannot do right before I go through, right, will I be there to go through it in an exam? No, right? So it will still be difficult, even you invest 1 more minute. So what is the moral of the story? Give up. Cannot do already, right? Put an asterisk. You guess, anyway, every one of you 25% probability, right? See who win. All right. Do not lose the time. And then lose the marks, the double loss. All right. Cannot do means cannot do. So this is the type of question that when they set in the exam, right? Honestly, do you think it's a fair question? Do you think it's fair? I think not fair. Very tedious, very tedious, because they have to involve a math, right? And then you eliminate, and then all this must become also, right? How to become when it's the first, you know, kinematics is like a third question in the paper 1. How to become when you're with holiday mode? Physics paper over already, I'll be free. I can tell you're waiting, don't pretend I don't know. You're waiting to burn. You're waiting to burn the physics notes, right? Right. I'm never going to study this again in university. I can study medicine, law, not physics, right? You can burn already. How to become when you see this kind of question? You won't become one. So therefore, the thing is, right, you must expect that. You must know one thing, guys. Today's lesson is not to teach you concept. I'm not here to teach you a normal lecture today. I'm here to tell you to understand if you cannot do right, what's the possibility that people beside you, I don't care what school you are from, RI, HCI, any school, you think he can do? You think the person can do or not? It cannot. So why spend so much time and then not being able to complete a paper? Okay, learn to give up. Move on. All right, let's go back to secret and close. That is my debrief for kinematics. I'm done with kinematics. The rest, which is on the secret and close, you all have went through June holiday. I'm talking to those who went through June holiday, right? You should know. All this I'm not going to reteach. For example, air resistance. The time taken to move downwards is longer than the time to move up. Air resistance and all this, right? You already know. Okay. Let's go over to the next chapter. Now, Cambridge do dynamics first, then forces. PMC do forces, then dynamics. Can I just tell you that in your order for paper 1, right, when it's a question, they normally set dynamics first, then forces. Why I do forces here in PMC? Because forces is when something is stationary, easier to analyze it. Okay, then I do dynamics when you're accelerating. Forces, the two concepts. The first concept is T and R. SOP is all here. Okay. Now, guys, remember, you use vector triangle method where you add up the vector, right, to form a closed triangle only if there are 3 forces on the body. If there are 4 forces, you want to draw polygon for me to solve. You only use vector 2 if there are 3 forces, and only if 2 of the 3 forces are right angle. If not, don't use method 2. Okay, don't use method 2. Use resolve method. Okay, resolve method, prove the force in the x and y direction is 0. And guys, PMC SOP in forces is to draw FBD. You cannot become smarter on that day of exam that, wow, I become very smart. Suddenly, I don't need FBD. Free body that I don't need. Example, people who don't draw FBD completely will be, they have a tension here, right? They gotta wait. They start to feel very smart. T sin 60 equal to mg. I know how to find tension. I equate T sin 60 equal to mg. You do not draw free body diagram, you forget that there are forces here at A which potentially have a vertical component. Therefore, it's wrong to say T sin 60 equal to weight, right? So you must draw the free body diagram completely first. And then you start to take moment about point A, find the unknown, slowly T and R, and solve. Unknown force at point A must be drawn, and the SOP is to draw AS and AY to the right and going up. Your school will say this. They will say draw F and theta. Okay, your school will do it this way. Do not do it this way. Your school will also find F and theta like this. Do not do that this way because the equation will be mathematically more tedious to solve. I know you can solve. F cosine theta equal to T cosine 60. We know you can solve, but variable not easy to solve. It's better to solve AS and AY first, then add up to find the net force, then find the angle. AS, AY can be negative. If it's negative, AS means to the left. Negative, AY means going down. Very straightforward SOP, follow it. No problem. Three forces intersect at the same point, you all know also, all right? Three forces intersect at the same point. That is a condition to get rotational equilibrium. This one you must also know, all right? Up thrust. Up thrust question, as long as you are submerged in the body, doesn't matter whether you are partially or fully submerged. It does not matter. As long as you're submerged in the body, you experience up thrust, which is equal to the weight of the fluid that you displaced. Derivation of up thrust you must know. This thing is called the 𝗟𝗏𝘃𝗧 principle. Okay, define that up thrust is the net outward force on the body, okay, which is equal to the weight of the fluid that you displaced, the 𝗟𝗏𝘃𝗧 principle. Okay, do not mistaken with the other principle called the principle of flotation, also known as the principle of common sense, because it's common sense. Because if you will have a beaker of water and then you have ice floating, agree? And then ice, of course, will have its own weight, which is blue color going downwards for the CG of the ice, which is called the weight of ice. And then you also understand that this body is partially submerged, am I right? So it actually experiences the outward force for up thrust, which is equal to the weight of the liquid being displaced, right? So this one will be actually the rho Vg of the water being displaced, agree or not? So you equate that, okay, the weight of the ice is equal to the up thrust, which is actually equal to rho Vg, true? This thing itself, right, in PNC, we don't teach it because it's actually based on the concept of static equilibrium. If you're not moving, then the up thrust must be balanced by the weight amount completely. But in your school notes, there's this thing called principle of flotation that states that when something floats, the weight equal to the up thrust. What? Of course, right? So they call it the principle of flotation. Don't mix up. 𝗟𝗏𝘃𝗧 principle is the one that tells you that up thrust is the weight of the liquid being displaced. Okay. Principle of flotation is that for a floating object, up thrust is equal to the weight of the ice. I mean, so that you're stationary in static equilibrium. You want to solve one question for forces that are thrust? Let me just find an A-level question for you to get some idea. Okay. Don't have. Okay, never mind. Let me move on. Okay, I will not give you any question for forces. I think forces is okay. We go over to dynamics now. For dynamics, turn over to page 10. There are two question types. One is called Newton's second law, F equal to ma. You all know the SOP for concept one? SOP, SOP. Draw free body diagram. My advice is draw free body of the system first. Okay, so you have A and B. You can draw body A alone, body B alone, or A and B together as a system. There are three types of free body diagram you can draw, but you need to draw system first. Okay, better. Then after that, you indicate the direction of acceleration, and last step you go Newton's second law, F equal to ma. So Newton's second law, what we can test you on will be understanding that the gradient of the momentum time graph is actually the force. And if you are given the force time graph, then the area under the force time graph give you the change in momentum, which actually is equal to mass V2 minus V1. Note that V1 usually is not zero. Initially, velocity is not zero, usually. They are moving already. So to not take the area divided by the mass, thinking that you will get the final velocity, That will only be true if initial velocity is 0. So please be careful about this. We call the change of momentum impulse in short. So that's a graph question that we can set. Okay, so please take note over here. That's first concept. I give you a highlight over here. During the secret and close, we give you an example. Let's say you got A, B, C, D, E. And we ask you to find what's the tension in the green color wire. So to find the tension between C and D, I call it TCD. How do you find the TCD? I ask back the first person from the right hand side. What's the first free body diagram you will draw? To find the tension is TCD. Don't look at my answer. Don't make it. Okay, what's the first answer you draw? What's the first free body diagram will you draw? A, B, C, D, E. Find the tension between C and D. Which free body diagram should we draw? The whole system first, right? The whole system, you got all the mass, you got the force here. You will know the acceleration. Agree or not? You will know the A, which is a good thing, a good deal, right? After you got the acceleration, how do you find the tension between C and D? Using PNC approach. How will you draw it? Free body off? Huh? Free body off? Yeah. C and I asked you to find tension between C and D. You can draw free body of C and D. And then you expose the pink and blue one. I don't want the pink and the blue. I don't want blue. I want green. You draw free body of A. I want the tension in green. You draw free body of A. None of his business. You draw free body of A, B, C. So that the only force that appear will be tension CD. And then you take the total mass times the A to get the answer. Agree? Guys, you need to choose the correct free body diagram to draw. Okay? Alright. Now, not so much, no use. Why not I give you an example of a A-level question? Everyone, take a look at the screen now. And I time you 2 minutes to solve question 6 now. Thank you, Matthew. Mm. No. It's not the same string. Not the same string. Mm-hmm. One minute has passed. So this is the actual timing. Then I give you 1 more minute, okay? Cool. This is also actual A level, so nothing very fair one. Okay, then engage your timing. Okay, 2 minutes. This is A level timing, 2 minutes. So you don't go beyond 2 minutes. Time start already, right? Then you stop already. Okay, no more. Stop. And let me check your answer. So, Ziying, well done. Joel, well done. Li Ting, well done. And Jonathan, well done. Khalees, well done. Matthew, well done. So those who submit answer actually got the answer. So I go to live on-site students. Can I have answer? B? You get B? Oh yeah, so sorry, too easy. First step is what? SOP system, right? System will be 54 minus 6 will be 48 Newton. Equal to total mass 8 times A. Immediately you get acceleration to be 6. First step. See? Within 5 seconds you get acceleration. Okay, if you compare to other people who draw the free body of 6 kg, draw the free body of 2 kg separately, right? You are way faster than them already. Okay, then you want to find the resultant force on 6 kg. Resultant force on 6 kg. If you get the MA, you want to find the net force on 6 kg. You will know the acceleration already, right? Answer is A. Okay, answer is B for this one. All right, good. So that is the dynamics first concept. As I go back to secret and close, and you look at the second concept of dynamics is on collision. Collision, definitely they will set. It is in one of the paper one. Okay, but because I think we teach collision quite well, so well that you can actually kind of reproduce everything and you will get full marks one, this one. Okay, so please look through the SOP. Your first step is that momentum. Can I ask Kenji? Momentum is conserved, right? Is it at all time or only before and after the collision, or is it at all time? At all time. So before, during, and after. But Kenji, if I give you 2 marks, why is it momentum conserved before, during, and after collision? Why? Because during the collision, there's a force when they touch each other, right? How can momentum be still conserved during the collision? How do you explain? Say. So understand the principle I want to test, the concept I want to test. Why is momentum conserved even during the collision? So momentum never changes. If you add the total momentum of A and B, right, together, right, okay, before, during, after, it will be the same. I'm not implying that momentum of A cannot change. I'm saying together it will not change. Why? Why is it that during the collision, the momentum is still the same as before and the same as after? Why? Because, so don't know what concept I'm taking to test. Because during the collision, there's a force, right? But this force are action-reaction as per Newton's third law. So they're equal in magnitude, opposite direction. So despite there having a force on both of them, but the net force is still 0, The net force is 0. That's why we call it isolated system. Am I right? That's why the momentum will not change. So that's how you answer. You talk about Newton's third law. You talk about Newton's second law. Newton's third law tells us that net force is 0. Newton's second law tells us that if net force is 0, why will momentum change? All right, that is the first concept on dynamics. That's the first step for collision. All right, conservation momentum. Then, of course, you need to look at elastic collision and inelastic collision. For elastic collision, remember UA minus UB equal to VB minus VA. This one for PNC, I think all of you already know. Okay, this UA, UB, VA, VB, VA, right? They are all vector. They are velocity. They are assuming that your direction is to the right. But if the diagram shows that you are moving to the left, right, this thing can be minus. Okay, this any of the 4 can be minus one. You must be careful. Okay. And of course, we've got explosion question as well, which I will not be going through. So that will be for dynamics. And you have all the mind map to tell you about the difference between momentum and KE and total energy and so on. Again, I will not go through this as we go over to work energy power. Work energy power is as difficult as kinematics in A level. The way they set work energy power question are usually require a bit of IQ aside to SOP. So the SOP alone cannot solve all work energy power question, okay? Because the type of A-level question they set not usual one. Later, you want to see, I show you, but it don't be two-step, okay? But first of all, we recognize that for work energy power, there are 2 concepts. The first concept is on proving the energy, KE, GPE, EPE, and 3 of them together, right, will only be conserved if no one do work on them. If someone do work on them, you must add the work done on them to get the final energy, and that is called the conservation of energy, right? So you must add. Please remember, work done being a scalar can be negative. One thing I will highlight, let me save your 1 mark first. If there's fission, right, the work done by fission is minus, we all know. Agree or not? Everyone also know. Who will not know that work done by fission is minus? Who do not know that fission take away energy from the yellow color so that blue color becomes smaller? Everyone knows it. But a lot of people, right, they minus away what? They minus away fission. They forget to multiply by the distance move. You know what I mean or not? They say fission 10 Newton. They go and K1, P1 minus 10 equal to K2. How do you use energy minus force? Be careful. Okay, distance. Okay, you are finding the work done by friction. Now in PMC, we say many times already, right? Do not use what you use in school. Gain in KE, loss in PE, work done against friction, work done by friction. Do not use all these things. All right, use template KE1, PE1 plus work done on the system. Okay, equal to K2, P2. By the way, the work done on the system, if work done by gravity, right? mg, H, right? Don't need to calculate because we take care of that for you already. Don't duplicate, Only work done by external agent. No, you know, use the spring, right? The spring compress, right? Force down, distance X, right? Do not add in work done on the spring, Why? Because we calculate that for you already. Half KS squared. The moment you try to find work done on the spring, right? You compress it, right? You will say what? You will say it's F times X. Agree or not? That will be wrong. Why? Because the spring force is not a constant force. The spring force increases with distance. So the actual work done on the spring as you compress it is not Fs but half Fs. And that's how you get half Ks squared. Okay? So therefore, spring, do work on spring, don't care. Gravity, don't care. We help you. We call it G, PE, and EPE respectively. Equation for power, concept 2, is on the gain in energy over time. Okay, the change is important. In the school lecture notes, there's no change. They put on E over T. Now today, I think I'm very powerful. I tell everyone I'm very powerful. Why are you very powerful? I can run at 100,000 joules with a K of 100,000 joules of energy. My K is 100,000. But if I run at the same speed, am I powerful? Do you have any power? Do you gain any energy? No. You must gain KE, you must gain GPE, you must gain EPE. Okay, you must do work against friction. You must have energy. Change, then you have power. If energy is the same, K is the same, no matter how fast you move, no power. So it's change energy over time. Okay. Note, looking at this equation here, change energy over time, right? There are two types of questions that they can ask. They can ask you for the average power or instantaneous power. Average power is usually over a duration of time. Agree? Like over a duration of 3 hours a day or 2 hours a day. How much energy you gain? So you just, okay, so in 2 hours, right, I gain how much energy? You use delta E over T to find average power. But can I ask instantaneous power? Can. Meaning at this moment, how much you gain from me? How much you learn from me at this moment? Okay, now, how much instantaneous power? Then, of course, you will use the gradient of the ET graph at the instant. Gradient already. True? Meaning, if I ask for instantaneous power and you're using ET, right? E over T, right? Then I must use ET graph. Then you must use the gradient at the instant. Now, the other option for you is to use work done over time. Work done being force and distance. And then you can summarize everything to force and velocity. Now, when you want to use work done over time, right? Don't say you want to use work done over time. Say you want to use FV. You will never use this thing to solve question one. Never one. You either use delta E over T or you use FV. Okay? This one is just a transition stage to bridge one to the final two. All right? So you choose. You want one or you want two. You don't use this one. Do not. There's a reason. Don't explain now. Okay? No time to explain now. FV. How to use FV? Ask you to find average power. You say force times speed. But the velocity must be average velocity. Guys, think about it. If speed increase from 0 to 10, speed increase from 0 to 10 linearly. Let's say the velocity increase from 0 to 10 linearly. Constant acceleration, constant force, 0 to 10. I ask you to find average velocity. You say you use force times velocity. Do you use the speed of 10? No, 10 is the maximum speed. 10 is the speed at the end of the day. You use the average velocity. You don't use 0, you don't use 10, you use 5. How do you find the average speed, by the way? Average speed is distance over time. Distance is the area. Another graph divided by time. So that's why you get half of V. Agree or not? So therefore, this one you have to be careful. You really have to be careful. Okay. If you use FV to find average power, actually I don't recommend. Find average power, just use method 1. But you want to use method 2 to find average power, right? Your speed is not the 10. It's the average, it should be 5. But if they ask you to find instantaneous power, right? I highly recommend this one. Good. Because you take the force, right? You does the speed at the instant, no? Then you get the power at the instant. Then I got another problem. You know what problem I have? We are full of problem. The whole world think that force is MA. I give an example. I got a car. So this is forced by the engine. And then there's a friction here. Then of course the force by the engine must be more than the friction, then you will boom accelerate. I say, hey guys, help me find the power of the engine. I want to know how powerful is my Ferrari. You say, very easy, Mr. Sim. Take the M times A times V, MAV. Wrong. This force is not the net force. This force should be the what? You want to find the power of the Ferrari, right? You need to know the force provided by the engine of the car. All right, so therefore you should use the engine force. What should you do to find the engine force? Go back to what chapter? Dynamics. Back to dynamics. First step, free body diagram. Second step, acceleration. F to the MA, find the engine force. Then sub inside here. Then multiply the speed at the instant to get the power at the instant. Don't forget that. Too many people, even teacher, put out MAV. Okay, sometimes they put MAV correct. How come correct? Because sometimes no friction. No friction, then the net force will be the force by the engine, right? Do you think I will set a question where there's no friction? In fact, I will set a question where we go out the slope, true or not? Then I conveniently test you on dynamics as you go out the slope. Find the engine force by FBD. All right. So this is work energy power. It's not, it's engine force. Okay. Okay. It will be only F net if there's no friction, then the engine force will be the F net. In simple words, you want to find the power of the engine, you use the force of the engine. Very fair, everything is fair, you know. Like you want to find the someone ask, what use average velocity? Speed increase from 0 to 10, right? From rest to 10, right? Use 10, But you want to find average power, you use the maximum speed. You use average, right? So everything is very fair one. Okay. By the way, sidetrack, because today lesson I didn't prepare. I just come here to talk to you one. I want to ask you, when you solve question in paper 2 and 3, right? Can you divide the space into 2 column or 3 column? Then you do 2, then cannot already, right? No space and 2 and 2 and 2. Okay. Do not just do and then wrong. Wrong. And then no space. And then try to like that. How to mark? Impression important. The people cannot see your face. Like you see, every one of them online off their camera. I don't know who is smart, who is not smart. I can only judge you only. Right now. You do like that, very terrible. The examiner will not like you one. Okay. And they will not like they have to like you. Actually, they should like you. So that ECF is easier to score. Because we cannot get everything full marks. ECF also depends whether you like me or not, right? Okay. You do one column, nice top-down approach. Okay. If you feel you are wrong, right? You are always too overconfident. You are too confident that you are right. You're also too confident that you are wrong. You think you are wrong, you can use ink. Ink. Cannot erase one. Ink. Wrong. Don't do that. Come on. Use pencil first, all right? Because a lot of times you think you're wrong, but actually you're right. Okay. So don't need to use ink to cancel, pencil to cancel, and then go to the next column. Okay. At least you can come back to it later on. So please plan your space. Do not go center already, right? Then after that come here, then tell the examiner, hey, look here, like that. This thing I marked before. Okay. Always actually. Guys, normally guys, right? Girls are very nice one. It's like, wow, I very impressed one. Okay. Power is done. I want to solve a question on power, on word energy power. This word energy power question, right? If you cannot do right next time, right? In your paper 1, right? Cannot do right. Seriously, trust me, you skip. You don't know how to do. They also do not know how to do one. They all don't know one. Okay, you just skip. I got a lot of word energy power question from the A level, the unusual one, or across the 20-30 years history. They're all not the normal one. Normal one, you can use SOP. I won't show you. Okay, we solve an unusual one now. Okay, go. When A level have a word called possible, right? When you see the word possible in the paper, A level paper, right? It means it is impossible to get the exact value. If not, why say which is possible value? Means it's not possible already to get the exact. Meaning you don't get the answer by calculation already. You did by more of a guess and check, elimination. Which one is possible, ma? This is important advice to you, possible versus calculate the value. That is different. Calculate means you can calculate. Command word you must understand how to do this one. Okay. Actually, 2 minutes very easy. Time's up. You will find it very hard to do. Okay. But you must check which one is possible. Okay. I don't know what's the answer because I don't have the answer here, but let me see. LOD, hi, no time no see. Okay, you're not going to on your camera, let me see you for one last time. Saying, okay, I think all are wrong. If I'm not wrong, let me see. I think all are wrong. Okay, thank you for those who submit answer to me. All seems to be wrong. All wrong, all wrong. Until now, Matthew, you're right. The rest all wrong. How can she? Any answer? You think it's 𝗵𝘵𝘆𝘀? You do guess and check, right? Okay, tell me how you think it's actually D. K again? K cannot be 10. Okay, A is confirmed wrong one. Because halfway down, K cannot be 2, is it? EPE also cannot be 10. Okay? Do you all agree with this statement? He feels that, of course, everyone knows that halfway round, right? Halfway down, the GP should be 12. Common sense. Yeah. Even if I draw the graph for you, let me draw a graph for you. We draw energy against distance. Okay, energy against distance. Okay, let me draw GP for you. I will use GP pink color draw for you. So you go down, GP go down. This is GPE, GPE. Initially it's 24, right? This is 0, right? So halfway down must be 12. This one we know. See? You invest time, right? Still cannot do right. At least your probability of getting the right answer cannot be 25 unless you're not even thinking in the 2 minutes. If you're thinking, you will know that one out of the 3 options really. Then you tell me that A, B, and D, what do you look at next? Can you be more systematic? You want to look at K or EPE first, then I will know what to teach. Look at EPE first, okay? He said look at EPE first. Okay, look at EPE. Okay, we look at EPE. Now, initially, right, would that be EPE? When you first fall down? Don't have, right? I mean, you jump down, right? Initially, there will be no EPE, right? Only after the distance you move is longer than the original length of the rope, then EPE kicks in, agree or not? Okay? I don't know how long is the rope, you go bungee jump, I do not know. Anyhow. Okay, maybe this is the L, the length of the rope, right? Maybe EPE will kick in later on, right? So let me kick in EPE now. All right. What's the shape of the graph? You all use signal. Tell me the shape of the graph. What's the shape of this graph? Linear? Happy face. This way, Do you agree that EPE at the end will be 24? Agree, right? So not pure guess. Use concept or not? Is understanding that EPE being half KS square a happy face a concept? It is, right? It's understanding that EPE start from 0 at this point, increase at the increasing rate to 24 a concept. Yes, yes, EPE. So therefore, you try to estimate that at the halfway mark. That EPE will be 0 already. But anyway, EPE must be quite small one. Agree or not? So therefore, answer is therefore D. Again, if you don't know how to solve it just now, right? If I don't debrief, you still don't know, right? Will you want to spend 1 more minute on that question? You should not. Don't know, right? You made a best guess, then you put an asterisk, then you move on. Somehow, I hope the question can be a bit difficult. So that at least you can show that you can do things that not everyone can do. Okay, somehow we also hope it a bit difficult. If everything very easy, not very nice also. Okay, I just give you one question on what energy power can, since I got only 20 minutes left. I'll give one more. So that when you don't know how to do, right, you score yourself. the easy question where you think it's difficult. Then you think, wow, it's very difficult. Actually, it's not because it's very difficult. It's because you are not. You overthink. Go. 1 minute, we'll do it. This one minute. You all try. Underworld energy power, A-level question. What's the work done by the engine? Engine force is F. This is already kind to you already because no friction. Then the only force will be the engine force, right? The net force will be just F. It's very kind to you already. Okay. Let me ask Joel. Joel, what's the answer? Joel, any answer?
Still doing.
1 minute up already. You need 1 more minute. 1 more minute. What's the answer? Because I say all this, you don't dare to call me, right? You say you don't know, you will scold yourself. Because this is the problem of overthinking. Sometimes, right, it's not about knowing more. It's about knowing less of the wrong thing. You don't know all the wrong thing, you're already very good already. Clean shit. What's the answer? Easy one. Ready? Like 1 second can get answer one. Huh? A. You think A. Next person. I said that no one wanted to give me an answer. Very funny, you all. Can you say D? Huh? What's the answer now? Answer? D, right. The work done, right? The work done will be, of course, the gain in energy, right? I mean, there's no friction. I will say the work done will be the gain in the KE, right? Answer will be D, true? Half mu squared minus half mu squared, very easy. Don't even do one. But you're thinking about what? You starting to think about power already, right? And then FV lah, all this. Since everyone want to think about power, right? Wait, I check. Oh, don't have it. Well, never mind. Change it into a structured question now. On the spot, find average power. Give me the expression for average power. Find the average power now. Got it? Kenji, what's the answer? Average power. Answer. Give me the answer. Half. Say again? Half M. Over 2? Oh, over T. Okay. Can I not have the answer? My question not clear. Can I have the answer in terms of U, V, and F? You know, paper 2, right? You shouldn't introduce one more variable. It's like, well, you want to introduce at one time. And then, of course, you will know. Okay, can you not do that? Thank you. Yeah, right. Technically, but I want to force you to use method 2. I give away the hint already. Did I give away the hint just now? I did, right? Then you'll know why I want to force you to use method 2 already. What's the answer? Go on, one more time. Force. Find the average power. Force. U plus V over 2. Confirm or not? That will give you your, instead of average velocity, is that, do you know why you find average, you add together by 2? Do you know why? You know why or not? This is initial velocity U, right? This is final velocity, true or not? Time T, agree? So to find the average velocity, right, average, you usually use distance over time. The distance is the area under the graph, that trapezium. So your half comes from the trapezium. Half U plus V multiplied by perpendicular distance, which is T, agree? T cancel. That's why you add together, you half it. But it seems like very strange. It's like the day you come out on Earth, right? You already know temperature increase from 0 to 10. What's the average? 5. You just know divide by 2. Why not divide by 3? Actually, the half is called a triangle. Area of triangle is half base type. The half comes from there one. Okay. All right. So this is what actual power. There are many other things that is actually important as well, and which is already discussed in the secret enclosed. For example, the energy time graph and energy distance graph. Please be careful, huh? MCQ question, please look at the axis. Is it time axis or displacement axis? They are different, huh? So the fourth graph is in your secret enclosed, please take a look over there. Okay, and then we have circular motion. Now, circular motion, normally they set this question combined with gravitation, the satellite question. So circular motion, not a big deal. I think the only thing that you need to know is that V is R omega. That's the first equation that you need to know. Velocity is equal to R omega. And the second equation that you need to know would be A is V squared over R, or A is equal to R omega squared. Okay, that would be the second equation that you need to know. Should I give you an example of... Oh, I want to remind you that for circular motion, please remember that it is a vertical circle, right? You will need to use the SOP from work energy power. Because in a vertical circle, the speed is not constant. When you come down, you lose GPE, you gain KE, right? So you therefore do need to use conservation of energy. All right, as a fact. And you want one question on circular motion? Okay, let me give you one question on circular motion. You will not like it one. Because the question I choose, right, it can be used by PNC SOP, right, which is most of them can. Then you will know how to solve already. Okay, I solved for you question 14 to let you see whether you can solve question 14 or not. This is from A-level paper, not the usual type of question. Okay, okay, I give you 1 minute. You try and see whether you can solve or not. One minute passed already. So let me ask, okay? Let me ask on-site student. This question confirm is like circular motion, right? Combined with what chapter? Circular motion at what chapter? No idea. Circular motion at what chapter? It's actually measurement. Because the convert unit, so it's like circular motion and measurement. Any answer? Okay, well done, Joel. Okay, well done. Any answer? Any answer? Okay. You all don't respond to me. I don't give you free lesson already. You want me to extend? Don't want me to extend. Okay. I can give you free lesson. You respond. What's the answer? No answer. Curlis? No. Okay. Now, how to do this question? Okay. This is funny. Everyone expect them to test on V equal R omega, right? Agree? Everyone expect them to test us on centripetal acceleration is V squared over R omega square. But they're going to test on the length of the arc equal to R times theta. S squared R theta. So that was the question here. So looking at S squared R theta, by right, we all know that the unit should be in radian. This is math. Everyone should know, right? It's in radian. And this will be in meter. This will be in meter. S squared R theta. Okay. So they asked me, what is the diameter of the circle of light produced by the moon? Okay. So the moon is here, right? This is the moon. You shine a little on the moon, right? Okay. So the diameter, right? generally it's actually the length of the arc. Correct. I mean, this is an assumption that we make every time when the angle is supposed to be small. Then you ask me, why is it, let's say paper 3, right? State why is it reasonable to assume that angle is small? Well, because the laser should be very, very far away from the moon. Is it the moon? From the moon, no? So that's why angle should be very small. And therefore, you can estimate that the diameter of the moon is the length of the arc of that big circle. Agree or not? So of course, that's some assumption. I'm talking about 2 and 3 now. Okay. Now, as for r theta, you want to know this is r, this is theta. Then you say, oh, very easy, ma. R theta. How come all the options are r theta, right? Look at number 1. Then you realize that he want to make it difficult for you. He want the r to be in kilometer. It should be in meter. Okay. So he want this thing, the r here, he want it to be in kilometer. Agree? Now, guys, and this is the type of question that we actually PhD went through in the June holiday, and also after the June holiday, I asked you, this is what the examiner want. He wanted to be in kilometer, but actually it should be in meter. So now the question is, should you change what it should be to what he want? Or should you change what he want, kilometer, to what it should be? The rule is like this. Every people want different thing. Every customer want different thing. You should only change what they want into what it should be. It should be kilometer, right? You must change it to what it should be. Not meter to kilometer, but change kilometer to meter. Agree? How do you change kilometer to meter? How? Or you say, oh, from kilometer to meter, will the number get bigger or smaller? The number will get bigger. So you will therefore change it this way. All right. And this whole thing will be, of course, the radius in meter. That's what it should be, right? And then I change color. The angle, it should be in radian. If it's in radian, there's no need me to do anything. I would say finish. But what the customer want, this is the customer, the examiner, the customer. Customer say, no, I think I only know how to do it in degree. That's what he want. That's what the customer want. You have to change it to what it should be. It should be in radian. It should be in radian, right? So you change it from degree to radian using your math. And you get your answer. All right. That is overview of circular motion. For gravitation, it's a big chapter, and definitely we will set a question on gravitation in the exam. It's a very big chapter in the syllabus itself. You all have run through the mind map, so you understand about the left-hand side being the force, and the right-hand side being the energy. Let's talk about how we set the question. Why did A-level set a chapter for you and ask every A-level students in Singapore to memorize, to study the equation to calculate the magnitude of force, also known as the Newton law of gravitation? Why? Because we want you to recognize that this force which exists between M1 and M2, and usually this M1 and M2 will be planet, or maybe the sun and the planet. This force is the reason why the planet can go around the sun. So why we ask you to learn this is to let you understand that this force will be equal to MAC mv squared over r mr omega squared as we combine with circular motion. You need to show the examiner that you have that learning objective. You achieve that. You must say the gravitational force on the satellite, the gravitational force on the Earth provides the Earth with the centripetal force to move around the sun. You must say it. And then you equate this thing to mv squared over r mr omega squared as per SOP. Now, students watching this video, if you are not our PMC student for some reason, you may not understand what I mean by SOP, but generally, that's an SOP for everything, okay, in terms of circular motion under our type 2, okay? So this one is for you to know, all right? Now, let's go back to the main summary for gravitation. Left-hand side is force, right? How about the right-hand side? Right-hand side is energy, potential energy of the system, M1, M2. Now, some of you ask me, the potential energy of the system is minus G M1, M2 over R. Do I need to multiply by 2? I ask why. Why you ask me this question? She replied me that minus G M1, M2 over R is the potential energy of M2. And then, because it gets 2 mass, therefore there's a need to multiply by 2. You must understand that this equation here is to find the energy of the system. If in the whole universe, there's only Earth, M1, there's only M1, there's no other people in the universe except for Earth. Do you think Earth will experience any force by anyone? Do you think Earth will possess any energy by anyone? No. He's not even inside the G field of anyone. You're the only person on Earth. Only person on Earth, Earth and you cannot. You're the only person in the universe. Then you're not even inside the G field. So in general, all our force and energy is for the system. All right. So this is for the system. There's no need to multiply by 2 again. Now let's go back to the question. Why did we ask JC students to know how to calculate potential energy of the system? Why? Combine with what? Work, energy, power, conservation of energy. K1 plus P1 equal to K2 plus P2. We want you to be able to calculate the potential energy so that you can apply it to conservation energy where you find the escape velocity. Now, this is too much. For me to cover all this, right, it's really a lot because gravitation is a very big chapter. One question that they actually ask is like, they ask you to calculate the escape velocity. Then they give you the temperature of the gas in the environment. For the temperature of the gas, right, can you find the root mean square speed of the gas molecule? Can I ask you? What do you find the root mean square speed of the gas molecule if I give you the temperature of the environment? Louder. Average Ke equal to 3/2 kT. Confirm A, see? Confirm A. Average Ke equal to 3/2 kT. Average K is half mv squared, where V is Rms speed. Am I right? Should know half mv squared, okay, where m is the mass of the molecule, not the entire gas in the cylinder. Half mv squared is the mass of the molecule. Be careful. They will give you the mass of the gas, so you must divide, find the gas mass of the one molecule, right? Half mv squared equals 3/2 kT. T must be in Kelvin or degrees Celsius? Kelvin. So you know she's very good. She sub in temperature, she get the root mean square speed. Then she check the root mean square speed. Is it more or less than the escape speed of that planet? It is more, means what? Can escape. Means will you find that gas in the environment, in the atmosphere of Earth? Cannot. Okay, escape already, right? Escape already, right? So therefore, this is a good application question for escape speed. I hope they test and I hope you know. Okay, if the speed is less than escape speed, means you'll find in the environment. So obviously, the oxygen, nitrogen very weak, very weak. Cannot escape. They are still here with us. Okay, now let me see whether I want to let you try one A-level question for gravitation, and then I close up there. Okay, let's try one A-level question on gravitation. Is it? Oh, too small for you. It's not a good. I'm sorry for that. I'm very sorry for that. But can I read the question first? Then I show you the. Because I know that you all don't have the question, right? So you read the question first. Help me check which of the graph give us the gravitation field strength. So what's the equation for gravitation field strength? Get ready. So you all know it's Gm. What you're flip? You all don't know, man. Gm over R square, right? This R is the distance from the center of Earth, not the surface. Okay, Gm over R square. Which one show me the G against R graph? Which one? Which one? So initially it's at 64. They say, oh, initially it's at 64. Initially at 64. So which one? Which one? So I'm sorry that. Okay, very fair. I show you option A and B first. Then you check which one first. Then later on you see C and D. Can? Okay, A and B. Which one? This A and B. Okay, got it? A and B done. Okay, then you look at C and D. So do you find any correct answer or not? If you find correct answer, then I don't need to show you C and D already. Is there any correct answer? A or B? Anyone? Online students? A and B? Joel want choose A already. Matthew choose A already. Curtis choose A already. So only choose A. You want to see a C and D or not? This is funny, right? This one. This is funny, right? Okay. C and D. Who wants? This is for 1C. Last person. What's the answer? A, B, C. Again? A. Okay. I understand the equation is GM over R square. That's the magnitude. All right. So why do you choose A? Say again. Or use calculator. I didn't ask you what you use to choose A. I asked you why and how you choose A. Okay, tell me, allow to explain now, okay? Because when it's 64, right? When R double, what happened to G? Decrease by 4 times, become a quarter lah. So 64 becomes 1/4 later, it will be somewhere around here, right? Is that right? And that's why answer must be A. So it's a 1 over S square function, not a 1 over S function, right? If I change this question to potential, then answer will not be A, right? It will be what? Don't play that. You stop first. Okay. So generally, you must understand this is how we test the equation. Okay. And by the way, some of them ask me, let's say this is a planet. Okay, this is a planet. Do you think the G will be 0? Will it be infinite at the surface of the planet? No. The asymptote, right? Actually, we all know 1 over R square. 1 over R square will have an asymptote, right? 1 over R also got asymptote, honestly. Where's the asymptote? The asymptote is not at the surface of the planet. It's actually right at the center over here. So if you really extrapolate, which is useless one, because it's not, because your equation, right, is only valid outside the planet. You all know now. That is only when small r is bigger than or equal to big R, the radius. When big R is the radius of the planet. Inside is a different story. Right? So if you extrapolate, right, which is useless anyway, then you will see that it goes to infinity. So if it's not going to be infinite, there will be a discrete value on it for G at the surface. Similarly for potential, some of them tell me potential is infinite. Why you say infinite? They say R is 0. I said R is 0 is when you're at the center of the Earth. Since I thought about it, I have no choice. Should I talk about what happened inside the planet? If G equal to GM over R square is only valid for G field outside the planet, then what is inside the planet? What's inside the planet? Today we see. Oh, you're very good. You just watch Netflix. I'm very tired. Okay. So yours tell me that is like that, right? Surface like that. So it's like that. True or not? Tends to 0, Yama. This is where G is GM over R square. Agree? So in fact here, everyone look here. This is you want to find here, right? You expect the answer to be 9.81, right? Okay. I promise you, if I take the mass of the Earth, I divide by the radius of the Earth, big R, I square it. By right should be close to number 8. By right. True. This is called the discrete value. Agree? What happened inside? So let me ask randomly. I ask you, what do you think is a G at the center of Earth? Have you ever actually thought about going to the center of Earth? I asked Elon Musk. Elon Musk said next time you're going to build a rocket and go inside the center of Earth already. But you're inside of center of Earth, what will be G? You feel what? You feel? G will be equal to what? Heavier, higher than number 81. Would G be higher, lower than number 81? What's G at the center? At the center. Hey, got this movie, right? You're not my generation. I pass it to ask. If I ask them, you all know how old I am. You all got this movie, is it? Go to the center of Earth, journey to the center of Earth. You all got watch? You're not my generation, never mind. Okay, what's G at the center of Earth? 0, 0. I mean, of course, why? The reason why we feel G, right, we feel a force pulling us down towards the center of Earth is because of the whole Earth is here, right? And then you are one tiny person, right? And then he pull you down, right? With GMMO R square, true or not? Okay, it's actually the mass of Earth that result in the force on you, right? In fact, the bigger the Earth, the more attractive it is. The heavier you are, I find you more attractive, right? The greater the gravitational field strength. Agree or not? We all know this. Now, if I'm going to talk about center of Earth, it should be 0, because at this moment there will be no mass pulling you to the center. But even you can tell me that, but Mr. Sim, this Earth is made of many mass around me, if I'm a center, but they will pull you. They will pull you outside along the radius, right? And that force is still 0, agree or not? That's called concept. But I think we don't want concept. We want math. Let's talk about math over here. What happened at the center of Earth with us? So you say G equal to G m over r squared. Agree? Agree, yeah? This one is only valid for outside the Earth, right? But inside the Earth, right, I'm going to break the mass into what? Replace it with density times volume. Why? You ask me why. This is the same thing that you do for upthrust in forces. When you replace the mass with density times volume, volume will be 4/3 pi r cubed. Agree? And therefore, this equation translate. Generally, I replace the mass and break it down into density times volume because I know that when you're inside the Earth, not the entire mass of the Earth is pulling you to the center of Earth. I will break it down. I will express it as a function of r to tell you who is the mass that is pulling you to the center. And therefore, what I get will be the g, the density, the 4 or 3, the pi, the r cubed, r squared, r. Boom, finish. I get this equation. And therefore, I realize that if you look into Earth, the g is linearly related to r. It's in the form of y equal ms plus c. It starts from 0 and increase linearly all the way linearly to 9.81 at the surface of Earth. Okay, that is what happened inside Earth. And to do that, you break it down. Okay, now my 2 hours of lesson of non-stop talking, okay, is really impromptu. Is to show you that, to give you the confidence that actually you should be able to do very well for your physics paper. I have to wish you luck. I know you don't need the luck. What you really need is the mindset and the skill set. Mindset is that you go in the exam hall, you must know that you are already going full marks because of who you are and what you have been through. You have the physics cafe, physics secret and close. You are already full marks already. Slowly allow yourself, be gracious. Lose 1 mark, 2 marks is okay. It's not the end of the world. All you want is just very simple. Get an A, come out. Okay, go in, get an A, come out. Finish. Enjoy your army after that. Guys, very sian, right? Very sian, enjoy your army. And the girls, wow, cool, man. Don't need to wear uniform already. All right, you get to enjoy. And I take this opportunity to ask you if you want to join us as a teacher. Okay, if you are inspired by physics in Physics Cafe, come and join us as physics teacher. Primary school teacher also can. So come and join us after your university if you want. All right. Okay. Goodbye, everyone. And that's really my final lecture. That's your final lecture. And I hope that will be my final lecture for me as well. Goodbye, everyone. Bye-bye. Honor students, goodbye, everyone. Bye-bye.
Thank you.
Thank you and goodbye.
Thank you.
Thank you. Who's that? Bye-bye.